Screen, and this is day 2 of 5.2. We're going to rewrite and we're going to deal with the radicals and radical expressions today. I have some review of the multiplication, but we're also going to do some addition and let's see, and some division. So we've got some more detail coming up here. All right, so this is just a warm-up. I want you to try this. You're going to multiply these radicands. Well, you're going to multiply these expressions together and see what you come up with and then reduce it. What I did, the second one was a little more challenging because you have to mess with the fractions quite a bit. And the trick on the first one was to put everything under the radical because the indexes or the indices are the same. So I can just combine them and put that under the radical, and that gives me, and then I rewrote it in the power of 2's, and so it gives me 2 to the 7th. And again, you could do 7 divided by 5 is 1 with 2 left over, so 1 comes out and 2 stay under. You could do it that way, or you could write it out. You could write out, and how many groups of 5s can you get? Well, you can only have one group of 5, so only 1 comes out, but 2 would be left over. And the second one was a little more challenging because for 2 reasons. One, the indices are not the same, so you can't just combine what's under there. But I can rewrite them to look like this. Now, if the bases are the same, the bases x and x are the same, you can just simply add those exponents. So I added 1/6 and 1/3, same as 2/6, so add another 6, you get 3/6. So you end up with x to the 1/2. But you have to do a little finagling with this 8 right here. You know that 8 is 2 to the power of 3 because 2 times 2 is 4 times 2 is 8. Okay, so I can rewrite that like this. Now when I do that, I get 2 to the 1/2. Now I have the same base, 2 and 2. So then I can add those exponents, the 1/3 and the 1/2, and I get 5/6. So that one's a little more challenging, but it's good to exercise those brain cells a little bit, those little gray cells. All right, so now we have a quotient and we don't want radicals in the denominator, so we're going to have to reduce this a little bit. I would start, knowing that I can't reduce 2 and 9 and n and m, I would start by just separating out the cubed root of 2 to the n and the cubed root of n, 9m. This one's a little trickier because I want to get rid of that radical. Well, if it was a square, I would just multiply it by itself, right? But I can't do that. I need to multiply by something that will get rid of, so I have to have 3 of something under here. I have to have groups of 3 so I can get rid of the radical. Well, here 9, I might rewrite that and just say that's 3 times 3. So I might just rewrite that as 3 times 3. And I would know I'd need one more 3, and then I could combine these, and 3 times 3 times 3 would give me 9, or excuse me, would give me 3 3s, would give me 27. And I could get rid of the cubed root of 3 to the 3rd. Now, I only have one m here, so to get rid of that one, I need 2 more m's. The first time you do this, it just seems really kind of awkward. Remember, whatever you do on the denominator, you're going to have to do on the numerator. Whatever you apply to the denominator, you have to apply to the numerator. All right, so now let's see if I did it correctly. I'm going to start with the denominator. So I can combine all these underneath, and that's 3 times 3 times 3, which is 3 cubed. And m times m squared, I add the exponent, so I have m cubed. Good, because I know if I'm taking the cubed root of something cubed, I can simplify it. Let's look up here. 2 times 3 would give me 6, and there's an n, and then an m squared. Now I'm going to go one more step It doesn't look like I can simplify anything there, so I'm going to leave the numerator as it is. And then down here, the cubed root of 3 cubed is 3, and the cubed root of m to the third is m. So that is reduced radical form. In other words, this is as simple as it'll get. I don't have any exponents here that are greater than or equal to this one, and then I don't have any radicals in the bottom. I want you to try these. I'm going to stop the video. You can look at my work and see how we do. This is one where I wish we could do these together in groups in class because it's going to help you so much, but you'll have to do it on your own or call a friend. Watch it together. Welcome back. So we've got some reduced forms here. I chose to separate them out first, and then I noticed that I needed something to the 5th power, and 16 was 2 to the 4th power. So I had to multiply it by this, the numerator and the denominator, by the same thing. Multiplied that out, and that would reduce, I can reduce this then, simplify this, so that the 5ths go away, the 5s go away, and I end up with 2x. And then the top one is pretty straightforward because they have the same indexes. I can just put everything under the same radical. And I can't simplify that anymore. This one is a little trickier again, kind of like that when because the indices aren't the same. This is the 4th root and this is the square root. I thought, well, maybe I can try rewriting this. And sure enough, x to the 2/4 is the same thing as x to the 1/2. So now I have this written like this and this written like this. So I can add those two together, multiply and add the exponents, right? Now this one is a little trickier. 27 is 3 to the 3rd. So when I take 3 to the 3rd to the 1/4, remember I multiply. So that gives me 3 to the 3/4. And then I can have a same base here. Once you have the same base, then you can add the exponents, and that's what I showed you over here. So a lot of detail, a lot of little steps, a lot of rules you have to remember. But again, the more you practice them, the better you'll get at it. Now, I want to go ahead and add and subtract radicals, but I can't do that unless the indexes or the indices are the same and the radicands have to be the same. So that's the only time you can combine them. So if I look up here, all right, this one has the same index because that's a 2 and that's a 2. But right now, I don't see the square root of 20 minus the square root of 5. The radicands aren't the same. This one's 20 and this one's 5, but maybe I can do something with that 20. And that, let's look at the cubed root one. Cubed root is 16. So those, again, have the same indexes, or indices, but different radicands. So maybe I can rewrite that in such a way that I can combine these. Well, that's as simple as it gets. But this is 5 times 4. And the square root of 4 is 2, so that's 2 square root of 5 minus the square root of 5, or 1 square root of 5. Well, that one, now I can see, because I have 2 of this thing, and I'm subtracting 1 of that same thing. So that leaves me with 1 of that same thing. So this is 2 square root of 5s minus 1 square root of 5 will give me 1 square root of 5. And you can have the 1 there or not. It's not necessary. Now I can look over here at the cubics. Oh, goodness, this is going to give me a little workout, isn't it? So the cubics, well, 16 is 2 times 8, 2 times 4, 2 times 2. All right, so that gives me one group of 3s, so I can take one of those groups out. and I leave the other one underneath. Now 250, that's going to give me a little mental workout too, isn't it? I might just, well, I know that it'd be 25 and 10. That might help me out a little bit. This would give me 5 and 5, and this would give me 2 and 5. Oh, that, you know what? That's pretty nice because look, 1, 2, 3 of these guys. And so I can take those out of the radical and I can, underneath it, leave the 2. That's nice because now we have the same power. All right, then I just take -2 plus 5 gives me 3 of those things. And those things are the cubic roots of 2, which are going, oh my goodness. So when we need really precise numbers with radicals and not decimals, that's why we use the radicals, to keep things really, really, really precise. We can do all the work we need to do and then simplify it at the end. If we needed it, we now can translate it into a decimal. But this is as exact as you can get. All right, you're going to try some now. You can do a little addition, a little subtraction. Remember to look for like indices. I think it's spelled this way. And then you have to have the like radicands. And if you don't have those right away, you might be able to rewrite it so that you do get them. You may not. So try these and see how you do, and then I'll be back in just a little bit. Okay, so I started doing this one. Sorry about sometimes when I write on here, like at the end here, you can't really, it doesn't, it's actually an N there. And then this is 2 squared, so 10 minus 4 is 6. So that one kind of messed up a little bit. I'll write over here on this one. All right, so that was a little tricky. The answer then is 6 cubed root of 2 plus the square root of 2. So that's the answer for that one. I'm going to stop this again and write this next one. But look, they're all square roots, so maybe I can get the ones under to all have the same. They may or may not. Let's try it. I'm going to have a little trouble here with this. Let's see. There we go. Okay. All right, so I've pulled out the perfect square in here, and I ended up with 2 square root of 5, and then I pulled out the perfect square here, and it ended up with -10 square root of 6, and pulled out the perfect square here, and ended up 5 square root of 5. So since these have the same radicands and the same indexes, I can combine the 2 minus the 5 and get the -3 square root of 5. But the square root of 6 isn't the same radicand as the square root of 5, so it's just hanging out there all by itself. Now, when we do a product, okay, I know this is a lot of work. You're probably getting a good brain exercise today. When we do the product, we distribute like we did in the past. And we would get, we'll put the 2 out in front. It's a little easier. If you wanted to, you could write it 7 to the 1/3, but I'm just going to write the cubic root of 7. And I'm going to subtract. So now I'm going to multiply 7 times 7 times 7. Oh, that's interesting. I like it when it makes my life a little easier because this is 7 to the 3rd. So I have 3 of the same thing. It means I can take them out, and it goes away, right? Because the cubic root of 1 is 1. So I have the 1 here, or it's a -1. I'm going to rewrite it like this. You can write -1. Doesn't matter. And 2, a lot of times we like to write this in this form where the radical is second part. Doesn't really matter. Whoops, not -1. Oh my goodness, -7. Yeah, there we go. All right. Now, that's for just distributing it out this way. Now I want to multiply, basically I'm squaring it, I'm multiplying by itself. I'm going to use the box method. I still like using the box because I need the help to keep me organized. So the negative square root of 3 would go here, and the 2x would go here, and the negative square root of 3 would go here. So I do the 2 times the 2 is the 4, and the x times the x is x squared. Then this is kind of interesting. It really just gives you negative 2x square root of 3. And then this will give you the same thing, negative 2x square root of 3. So you can put the negative sign out in front. Now, a negative times a negative is a positive. Okay, that's nice. And the square root of 3 times the square root of 3 is that thing, 3, right? Notice these have the same indices and the same radicands. So I can simplify that whole thing to be the 4x squared minus, okay, I have 2 of these and 2 of those, so I have minus 4 of those. Square root of 3's, plus I have 3 of those. I know that looks a little funny. You could put the 4 with the square root of 3 and the x afterwards, but this is the cleanest way to write it. All right, now you're going to try some and then come back and see if we agree. This is practice, practice, practice. You guys are getting a good workout today. Okay, so there we have the simplified form. I multiplied 5 times the square root of 6, and I put the 5 in front, and then I multiplied. They have the same, so you're just multiplying. So if they have the same radicand, you can multiply. You can't add if the radicands aren't the same. Sorry, the indices are the same, so you can just multiply, put them together, but you can't add them, right, unless they have the same indice and the same radical. That's the difference between multiplying. So multiplying, you just need the same indice, and you can combine them underneath, multiply them underneath, and then I simplified that a little bit. All right, now we don't like those radicals in the denominator. But I have a binomial here. I have 2 pieces that I'm adding together, and one of them is a radical. If you remember from the past unit, we had what we called conjugates. And we found out that if we multiplied a plus b times a minus b, it would get rid of the radical. And you kind of did that in the previous problem too. All right, so to rationalize this, it's called rationalizing it because it's irreversible. Rationalizing means I don't have a radical in the denominator. So I multiply the numerator and the denominator by the same thing. That's just like multiplying it by 1. And I want to choose the conjugate. Now this is the same thing as the difference of 2 squares. So you could just do it that way if you wanted to. That's a nice simple way to do it. It'd be the difference of 2 squares be 4 minus 5, right? Or you could make your box if you don't remember all those rules. You could make your box and do the 2 plus the square root of 5 and the 2 minus the square root of 5. And you get the 4 here, and then you get a positive 5, square root of 5 and negative square root of 5, so those would cancel out. And then you do the square root of 5 times the square root of 5, which would be 5, and it'd be a negative. So now you have the difference of the 2 squares. So you do 4 minus 5 is a negative 1. That would be on the bottom. Now, when it's on the bottom, does it really matter where it is? If I'm dividing by a negative 1, I'm just saying everything's negative. So I'm just going to put a big negative sign out here. Now, 1 times this is just that thing. I am going to leave the parentheses there for just a minute because sometimes I forget that I have to distribute out this little deal right here. So it'd be negative 2 plus the square root of 5. There's a lot of detail going on here. And it's really easy to miswrite that. So, all right, hopefully that gives you a start anyway. Let's do these. I'm going to get you started, and then I'm going to have you guys finish it on your own. So to get you started, we multiply the numerator and the denominator by that conjugate, so that we add the square root of 3. So I'll get you started on these, and then you'll have to finish it out. So that'd be the 1 plus the square root of x, 1 plus the square root of x. All right, I'll stop it, and then you guys can finish it. You see here, we had to do quite a bit of multiplying when we did the b squared, a squared minus b squared, so it's 2 squared, which is 4, square root of 3 squared is 3. We subtract, that just gives us 1, so that can go away. But you're left with this top piece. None of these can be combined because the radicands are all different. So you have to write out each piece by itself. It doesn't matter which order, but each piece has to be written out by itself. Now over here, again, we get 1 minus x. We got rid of the radical sign, which we wanted. And then on the top, we're just going to distribute out. And it really doesn't simplify very much. It just gets rid of the radical in the denominator. This is an additional one you can practice. Again, you could skip this, or I'll show you the answer here in just a second. Okay, so I reduced this out. You can look through my work and see if you agree. When you get here, again, you have different radicands and you're subtracting, so you can't do anything, and you can't simplify any of those at all. Anyway, that's what you end up with, so hopefully you're doing all right on that. Here's a huge summary of everything we did for this section. A lot of detail in here. Finding the product of radicals, the quotient of radicals, and all the different property and how to rationalize a denominator, and then some examples there. You can look through those, take a picture, break it, and just look through some of those and write some of those examples down for your notes. The goal was that we could use the properties of exponent radicals to rewrite radical expressions, and you've done that. You were able to, if you were able to do those last things, you've used the properties of exponents, knowing when to add, subtract, multiply them out. You can also interpret the radical expressions that represent a quantity in terms of its context. So that's knowing, okay, when can I add? Only when the radicands are the same and the indexes are the same. So that's a 3, and then I have 4, the same thing, then I can add them. But you also know that if I was multiplying things, the indexes have to be the same. So then I can combine whatever underneath and multiply, and that's true for division too. This is true for subtraction. So if that's a 2 under there, as long as they're the same. That doesn't look like a 2, but we'll pretend it is. All right, I know this is a lot of new stuff. Some of it's review, but some of it's really just practicing and practicing and practicing. You'll have some Math Excel problems to help you along the way and give you some more practice and some more help on those Math Excels. See your teacher. If you have any questions, any specific questions, go to some office hours. There's all kinds of tools. This one does just take a lot of work. This is like running your sprints or something in your sport, just to develop your your muscles and your breath and whatnot. We're kind of running sprints here. Here, try this, try this, try this, and you're doing a whole bunch of things at one time. So hope you have success in this, and if not, reach out for help. Talk to you later. Bye.